If we're going to have a course on chemistry, the first thing we need to do is define the term. What is chemistry? And the good news is it follows the same format as other science definitions. It's the study of something. And I think it's worth our time to take a look at what that something is and do a little brainstorming. So I'd recommend maybe pause the video for a moment and think of a few ideas what could go in that blank there. All right, theoretically you're unpaused now. If we were in a classroom, I would try and ask different people what they think should go in that blank. But since we're not, I'll just tell you common things that people suggest. Chemistry is the study of chemicals. I think that's a pretty good guess. Chemistry is the study of stuff. Usually I tell people to dumb down their answers, the study of stuff. Chemistry is the study of chemical reactions or something, right? The idea is it's got to be the study of things around us, and we have a blanket term to define what are the things around us. They are matter. Now, just saying the study of matter is not necessarily clear enough. The two key things we're looking at in terms of matter are the properties of matter and the changes it undergoes. The properties of matter and the changes it undergoes. And that is our definition. So we're going to be hitting these terms at various points in time. In fact, it's a rabbit hole of definitions that we're dealing with. And the first one I want to address is matter. What is matter? Not what's the matter, but what is matter? So, again, we're a little hampered by the fact that I don't have anyone to ask, but what is matter? And I think commonly in earlier science classes, people will say, oh, matter is everything around us. And I think that that's a pretty good idea. Now, how can we describe everything around us? Well, everything around us takes up space, right? And you know that because you bumped into things, and you have gotten into things, and two objects don't occupy the same space. So part of our definition of matter is the idea that it is something that takes up space. And then the other part of our definition is that it has mass. So matter is anything that has mass and takes up space. Anything that has mass and takes up space. Now, as I said, we're going down a rabbit hole of definitions here. We're going to have to deal with properties as physical and chemical properties, intensive and extensive properties. We're going to have to deal with chemical and physical changes. And now we have to deal with this idea of something taking up space and something that has mass. So let's address those vocabulary terms before moving on. What is it to take up space? And I want to spend a little bit of time now addressing this, because we're going to be looking in depth at quantities and units later, and this happens to be very close to the definition of one of our quantities. What is it to take up space? And taking up space is a way that we describe volume. Okay? Quantities are generally of the form the measure of something. And in this case, it's the measure of the amount of space occupied by a sample. Amount of space occupied by a sample. And we can glance at some common units for that. You've seen volume on a day-to-day basis in things like a soda can or a gallon of gas. Soda can might be 12 ounces, right? Or a common plastic bottle of soda is 16.9 fluid ounces, which is 500 milliliters, which is half of a liter. All right, so we've got all these examples of common units for volume, things like gallons, or ounces, or milliliters, or liters, or whatever, right? So, again, in the not too distant future, we'll be looking at the quantity, volume, and different units of that quantity and how we establish units. So that is our idea of volume, and now we need to address this idea of mass. Mass is actually kind of a ambiguous term, but A simple definition is that mass is the measure of the amount of matter in a sample. All right. So again, since it is a quantity, we're talking about the measure of something. And in this case, it's the measure of the amount of matter in a sample. And I think that if you were to ask somebody, what's a common example of a unit for mass, one of the first suggestions people have is the pound. And although these words are going to be a little confusing, I want you to listen closely. The pound, a lot of pedantic individuals will point out, is a unit of weight, but pound can be used in two contexts. And the first context is the pound force, and the other is the pound mass. So yes, pound can be used for mass. In fact, it is implicit when you write the abbreviation LB that you're referring to pounds mass. All right? In fact, that's distinguished as pound M as opposed to pound F for force. All right? So pound can be a unit of mass. And I also want to point out a common question that I ask my students is, why is the abbreviation of pound LB? And there's a pretty simple explanation for that, and that is the origin of the term. Pound is from the Latin libra, so we have that Latin abbreviation right there. All right? And then another common unit of mass that we should be looking at, especially as we get closer and closer to our SI measurements, is the kilogram. All right? So we've got a couple terms here, volume and mass, as a way to define matter, and it might be useful for a moment to look at some examples of what is matter and what isn't matter, without some like, what's the matter pun. Ha 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 ha. Anyway, so what are some examples of matter? I had said earlier, matter is generally everything around us. So like this table, right, this marker, they have mass and they take up space. Your desk, your car, pretty much everything that you interact with in the physical world on a day-to-day basis. I think that something that tricks people very often, and I always ask my students, what about air, right? Does air take up space? And the answer is yes. You can take a balloon and fill it up with air. So air definitely takes up space. And then the second thing I ask them is, does air have mass? And that's kind of a misconception for a lot of people, because air does have mass, right? In fact, you can feel all the air stacked up on top of you, and that's the air pressure you feel, right? So air has mass. You just don't think of it as having mass because its density is so low. In fact, in your classroom, there's probably around 1,000 pounds of air, all right? It's just super low density, so you don't notice. What would be some things that aren't made of matter? Well, I think that abstract concepts, I always say love, since that's super relevant in high school times, and hopefully the rest of your life, or things like other emotions. And I do like to joke that while sadness can weigh your heart down, or you could be filled with sadness, it doesn't take up space and it doesn't have mass, so it's not matter. All right, well, we'll take that information on matter, and then we'll move on to this idea of properties. Changes is going to be the last thing we handle, but we'll deal with properties in this next section.